Hello, welcome to an informative session on earthquake engineering. Hi, this is Professor Sujit Velures Nair, Assistant Professor in Civil Engineering Department at Sakarchand Patel College of Engineering, Visnagar. Today we will be discussing about case studies, failure and its loss of casualties. The case study related to Bhuj earthquake that occurred on 26 January and Turkey earthquake on 6th February. We will be discussing these earthquakes. So let us start with the Bhuj earthquake. On 26 January 2001, Bhuj region of Kutch, Gujarat occurred an earthquake of 7.9 magnitude at 8:46 as per Indian Standard Time. Here you can see the casualties, injuries, losses, and buildings and dam damages. As per geological survey, here you can see the shale and sandstones are major found in the Bhuj region. In Saurashtra region, you can see the basalt formation is major, and near the Kandla port, major deposits of loose sand is available. The Indian subcontinent is moving northward at the rate of 53 to 63 mm per year and colliding with the Asian plates. Here you can see the three major fault planes are available: Alabun, Kutch fault and Katrol fault. These three faults are available. We all know soil is a complex material. It has different multi-phases like solid phase, liquid phase and gaseous phases. So in the Kutch region, generally loose sand is available, and which is being compacted, and due to the shear stresses and volume is being reduced. To the Terzaghi theory, effective stresses is equal to the total stresses minus pore water pressure, and the stiffness is directly a function of effective stresses in the soil. Pore water pressure increases, it will affect the effective stresses in the soil. So generally it behaves as a liquid. So generally this loose soil in the Kutch region where pore water pressure is increased, and this sand boils will be behaving as a liquid form. So you can see the pictorial form of a liquefaction occurring in near the. Due to the shaking of ground during the earthquake, you can see the cracks and damages observed in the region of railway embankment, and some of the filling stations are being damaged, severely damaged. You can see several bridge structures are also being damaged, like Rudra Mata bridge and Suraj Bari bridge. So here you can see the cracks being observed in the well caissons, and separation of pier with the soil also you can see in the Suraj Bari bridge. The failures are being observed in the Earthen dam also. You can see the longitudinal cracks, some of the settlement in the crust, and this intake well, near intake well you can see the failures of the structure you can see. Failures of structure at ports. You can see major of the ports are being damaged. Kandla port, you can see the loss of material, partition walls are being collapsed. In Navalaki port, you can see the sheet piles are being damaged. Some of the cracks are being also observed. The buildings are also being damaged due to the effect of soft story at Bhuj, different places like Bhuj, Gandhidham, Ahmedabad. You can see. So due to the bad configuration in the building also, you can see the collapse, water tank failure, overturning of structure in some of the places like Bhuj and Gandhidham. Some of the recommendations. Improvement in the strong motion of recording is needed. Micro zoning map should be developed, and peak ground acceleration should be upgraded. Liquefaction mitigation should be done some of the important structures. Seismometer should be installed. Implementation of building codes. Quality control should be adopted. Ductile detailing should be adopted. Low-rise building constructed using local materials should be improved. So these all are some of the recommendations. 26 February 2023, a Turkey earthquake occurred of 7.8 and 7.5 magnitude, which occur in the zone 1. So here you can see the casualties, injured, losses estimated, and damages during this earthquake. So first earthquake occurred at Gaziantep of 7.8 magnitude around 4:17 am, and after 9 hours second earthquake occurred of 7.5 magnitude at Ikanozu. Here you can see this was a major earthquake after 1939. Here the tectonic plate moves about 10 mm per year. So East Anatolian fault plains moves on the Arabian plates. So this movement you can observe. So due to this Anatolian fault plane, you can see the zone 1 is at a higher risk, and also as a geotechnical failure due to the soft soil and high water table, this failures occurs. You can see the buildings failure observed, like no beam or very thin column, poor joints, and also there are no continuity of longitudinal reinforcements. So these all are observed as a building failure. Transverse bar failure, no transverse bars, thick slab and poor joints, inadequate load transformations. So these all are the failures observed in the building. Some of the conclusion you can see: the thin column, thick slab, inadequate steel reinforcement, transverse reinforcing bar are not inadequate, no beams, or you can say nowhere seen the shear walls having greater than 10 story. Some of the surface ruptures also being observed. You can see the major cracks available on the surface of the earth. Some of the Goksidri. You can see the highway also being damaged due to this earthquake. Antaki and Dimizu highway totally failed. Some of the liquefactions also being observed on the ground surface. Tevikili and Kahraman Maras in the Turkey. Some of the landslide also being observed near the mountainous regions of Gaziantep. You can see the railway is being closed due to the landslide. Some of the sinkhole also being triggered out in a park called Yavuzlar in Gaziantep. So this is also one of the major damages. So I would like to thank Evangeli and George for contributing in the primary report on failure of multi-story building in Turkey and Syria. SPG Madhabhushan SK, IGI, Earthquake Engineering Field Investigation Team, and all the authors for contributing in the earthquake engineering. Thank you very much. Best wishes. Thank you.